Hi guys, a very good afternoon to all of you. Welcome to a session on modern maths from BYJU'S Exam Prep. So friends, before we get into this session and understanding this topic, I'm sure you all already would have noticed that the CAT basic notification has been out for 2 days now. In fact, today the registrations are opening up, would have opened up by now, I hope. I don't know if anybody's out there listening to me right now who already filled the form. I think it's too early to expect anybody to fill the form, but I will probably be doing it today in the evening. I and my teammates will be doing that in the evening today. So hopefully by the time I take the next session, I'll be able to talk about what is new in the form this year. Is there anything that is changed in the form per se? But that aside, we at least have some basic idea this time. First thing is, it is an exam conducted by IIM Bangalore. The second thing is, it is an exam which is conducted in 3 slots. Now guys, this is important for us because 3 slots usually means it's a 2-hour exam. So the notification did not exactly mention whether it's a 1-hour exam or a 2-hour exam. But yes, usually if it is a 3-hour exam, that is into 2019, 2018, 2017, it used to be conducted in 2 slots. Morning, they used to call it as forenoon and afternoon. Whereas once they made it into a 2-hour exam because of the pandemic, that is in 2020 and 21, they made it into 3 slots. Okay, so this year also they clearly mentioned that it is going to be held in 3 slots, so it is a 2-hour exam. Which also brings us to the next point, that if it is a 2-hour exam, I am expecting more or less the pattern to be similar to last year. Now, before we get ahead, please take a look at this. In 2020, the first time they made it into 2-hour exam, there were 76 questions overall and 2 hours. Then the next year, that is 2021, they announced beforehand that in 2 hours, 76 questions were difficult to solve, or we believed that it is not really a good number of questions. So they brought it down. This 76 became 66 and it was a 2-hour exam again. So in all likelihood, I am expecting this year also to remain in this horizon. 66 could probably go up to 68, but it will not decrease, I believe. 66 was a good number. I was really happy with the way in which the exam, the number of questions that came out in the last year versus the time available, because you only have 40 minutes per section. 43s are 120. So 40 minutes per section, you had 26 in English, 22 in quant, and of course 20 in DLR being the middle section, quant being the last section. So yes, so I felt it was good. So I don't think they might change too much, but then there is no way to know till the last few days. So they might come out with an announcement, they might not come out with an announcement, we don't know. So we'll have to wait and see, but typically till October at least you will not know what will be the exact number of questions. So that's as far as your CAT exam goes. Let's go ahead and take a look at today's topic now. So I thought I'll just give you some running commentary about the CAT notification. So I think these are the points which I wanted to talk about it. So now we're going to talk about the topic for today, which is modern math. Now when you're talking about modern mathematics, now some of you might be wondering, why is this called as modern math? Frankly guys, it is called modern math because not that it is recent. It is just a branch of mathematics which was developed quite late compared to the other branches. That is the reason we call it as modern math, nothing else, don't worry about it. But what are the topics that are a part of this? The topics which are a part of this are permutation and combination, probability, and some part of set theory. Okay, but in this session, we will stick to PNC and probability only. Set theory will be taken up later, right? So today we're going to look at modern math, which includes permutation, combination, and probability. I'm assuming that your basic knowledge of PNC is already there with you. You know the basic idea. So we're going to get into the problem solving part. But yes, Varun, thanks for asking. Yes, I am doing really well. Thanks for that. But yeah, a couple of pointers before we go ahead is what is the importance of this topic with respect to CAT and XAT, the two biggest exams. Let's take a look at basically what can be expected from CAT. Guys, if you look at an average for CAT from probability and from permutation and combination, you can expect one question, max two questions. Two also is very rare. Mostly one question for sure. Two questions is very, very rare, but yeah, there have been years where two questions were also asked, right? But again, that was in an older version where there were 34 questions. So two questions in PNC could have been possible, but in 22 questions, probably one question, in rare cases, two questions might come, okay? Number systems, advanced level, Kaushal, I don't know. I don't think I will take numbers. I really don't like the topic called number theory. So probably some other colleague of mine would be taking. I take topics which I enjoy. Okay, so there are two things. One, you know something. Two, you enjoy talking about it. So yes, I know numbers, but I really don't enjoy it. So probably somebody else will be doing it. But yes, I enjoy modern math, so I take this. I'm taking this session right now. Okay, what about probability? Probability in the entire, please note my words carefully, in the last decade, one question has come. Overall, I'm not even talking about one question per paper. In the last 10 years, one question has come. That too, it was in the last year or last before year. Usually, CAT does not get into probability, but in the last 1 or 2 years, one question has been asked from probability. Now, is it a change in the pattern? Are they asking about probability? Frankly, there is no data for me to talk much about, except for the fact that one question has been asked in the last 1 or 2 years. However, if you look at XAT loves this topic. If you look at XAT, you can definitely, so if you look at permutation and combination and probability guaranteed you can expect one or two questions, guaranteed. In fact, there were years where 2 questions and 3 questions have also come from PNC, from probability. Whereas PNC, you can expect one question. Okay, so in fact, I would give probability 2 plus, in fact, 2 or 2 plus, greater than or equal to 2, and PNC will be 1 or 2. So you can expect 3 to 4 questions from PNC and probability in XAT, whereas in CAT it could at best be 2 questions, both topics put together. So that's the importance as far as the topic is concerned. Now if you look at other exams like NMAT, SNAP and all, yes, they usually PNC will not be left by them. They always end up asking. SNAP asks simple probability questions. NMAT also asks simple PNC, simple counting problems, simple probability questions. So all these exams they definitely ask. Okay, IIFT also asks PNC, IIFT also asks probability. So almost all these top exams they definitely ask. But more accurately, if you're talking about CAT and XAT, XAT gives a more weightage to these topics compared to your CAT exam. So let's go ahead and take a look at what kind of questions can come. I hope the basics are in place for you guys. I hope you guys are ready with the basic idea. Okay, Kaushal, I don't remember whether the probability question came in 2021 or 2020. Please check one of the 2 years. I really don't remember, guys. My memory power is not that great. So yes, I tend to forget, but I remember that one question has come. Anyway, let's go ahead. The first question, very, very simple question as a warm-up for you. You should be able to do this in about 45 seconds and give me the answer. Your time starts now. That's 45 seconds, but I'll give you another 15 or another 30 seconds, 1.5 minutes ideally. So let's see how many of others can give the answer. Right now, Krishna and Sri Vishnu have given some answer. I will not comment whether it's right or wrong. Let's wait and see. if others can give the answer. Okay, Vicky has also given the same answer. Oh, either all of you are wrong or that is the correct answer. Let's wait. Okay, Vicky has given the solution also. Alright, so let's go ahead and take a look at this, guys. So what is happening here? What is the logic here? We have 10 numbers. So what are the numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, it could be any 10 consecutive numbers. Doesn't really matter. I've just taken the first 10. No problem. Because the answer will not depend on which numbers you're taking, right? Now, the question says number of ways of selecting 2 or more consecutive numbers. Now, first 2 or more means it could be 2, exactly 2, it could be exactly 3, it could be exactly 4 and so on up to I choose all 10. That is also all 10 consecutive. So let's start with exactly 2 numbers if I am selecting consecutively. How many ways can I select them? So 1 and 2 is one pair, 2 and 3 is another pair, 3 and 4 is another pair. Like that, I can select up to 9 and 10. So how many pairs can I select? I can select 9 pairs. If I am looking at exactly 3 numbers to be selected consecutively, then my series or my pairs, rather this time my triplets will be 1, 2, 3, similarly 2, 3, 4, 3, 4, 5 and so on up to 7, 8, up to 7, 8, 9 and 8, 9, 10. So how many triplets can I select? Starting from 1, 2, 3 as a group, 2, 3, 4 as a group, up to, I will go up to 8, 9, 10. So you can clearly see that I can choose up to 8 like this. So you can see a pattern emerging. If I'm looking at 4, you will notice that I can select 7 groups like this. If I'm selecting 5, I can select 6 groups like this. So up to, I'm selecting all 10. How many ways can I select all 10? Only one way. So I want the sum of all of these. So 9 plus 8 plus, so basically it is 1 plus 2 plus 3 up to 9. This is a sum of first 9 natural numbers, which is 9 into 10 by 2, n into n plus 1 by 2. So this becomes 45. Therefore, the answer is option B. Right? It's a very simple question, but then it can be done through permutation. Sri Vishnu, not everything. See, permutation is basically called as a counting problem. Its topic is counting problem. Okay, so permutation is a way in which things can be made easier. You don't have to put permutation every time. So there are certain questions which you will come across which can be done faster without using actually permutation and combination concept. Okay, so this we did not exactly use NPC or NPR or NCR. Without that, we got the answer in a very, very quick way. Okay, 9 factorial. 9 factorial is not 45, Varun. What will you do with 9 factorial? It luckily satisfied 10C2, correct. So 10C2 turns out to be 45, but that is not the correct logic. 10C2 basically is talking about number of ways of choosing 2 out of 10. So 10C2 is 10 into 9 by 2. Mathematically it will turn out to be correct, luckily. But that is not the right approach. Okay? Alright, that's good, Vicky, that you pointed out. Okay? So that happens in PNC quite a bit. In fact, PNC is one of the most trickiest topics, my friends. The reason I'm interested in this topic is because even today, I end up making small errors because something new in the question and I'm not able to comprehend, not about comprehending it, but not able to realize that something has to be extra done. So that's the reason why I love this topic, because even people who are really good in PNC will end up making mistakes once in a while because the questions can be tricky. So you have to decide whether PNC is a topic for you or not. Please remember, this is the month of August. You have 4 months left: August, September, October, November, and November not the entire month. So in these 4 months, PNC should be a topic to be picked up if you have already completed arithmetic, algebra, and some part of geometry. If you did not complete arithmetic, algebra, and at least did not start geometry, I would recommend keep your PNC away for now. But yes, you can attend the sessions, you can get some basic ideas so that anything easy comes, you can solve it. But don't waste your time on PNC without finishing arithmetic and algebra. Please remember my entire statement. I'm not saying don't read PNC. I'm saying don't do it if algebra and arithmetic is pending, because they are a lot more important topics than this particular one. Yeah. Yes, Kaushal, exactly. It is very tricky. Okay. Okay, Indian vlog. My friend, you come with names like that, it's very difficult for me to talk. But then he's asking, sir, can we get a normal B school at 75 percentile general? Now, first you have to define what is a normal B school. Okay, 75 percentile general, what is a normal B school? What is your definition? What kind of school? So give me some B school names and probably I'll be able to talk about them. But I don't think you can get any IIMs. In fact, let me put it this way, bluntly. None of the top 30-35 colleges in the country will take you at a 75 percentile as a general category. Okay? Right, let's move on. Varun, ideally mocks and the questions in the mocks should be helping you revise a topic, not to learn it. Guys, when you want to learn a topic, it has to be structurally learned. You can't randomly see. In a mock, some concept will be asked randomly. But that is not the way to learn a topic. So don't use mocks to learn topics. To learn a topic, a proper structure has to be followed. What will be the mocks useful for in solving the questions of mocks? Apart from the obvious things, the thing that mocks will give you is revision. Because, okay, you learned all the entire structure, one concept has been tested, then you'll think, okay, do I remember this or not? It's like a revision. You test for your revision. But don't use it as a means to learn a topic. That's a bad idea. Christ Bangalore, yes, you might get an 75-80 percentile. Yes. Okay guys, second question, not wasting too much of time. We have spent 15-18 minutes. Hardly one question has been done. Next question coming your way. A tricky one. I want to see how many of you get the correct answer. Give it a best shot, guys. This is a small, slightly tricky one. As usual, all PNC questions, in my opinion, are tricky. Kaushal says he got only 60 percentile. I got 4.5 months to prepare. That is last year, 4.5 months. You have 4 months here, so totally 8.5 months. Varun, yes, it might be useful, MAHCET. But MAHCET questions are going to be far more easier than CAT questions. So if you can do these questions, then MAHCET should not be a problem at all for you. Vishal, what is the answer? Simplify and give an answer. A, B, C, D. Okay, guys, that's about a minute and a half. Vicky, yes, you are right in saying that it is incorrect. Okay, so let's understand what is happening here. So the basic logic in this question is, there are 8 points which are non-collinear, which means you can't draw a straight line through any 3 of them. And you have 4 of them that are collinear. So totally there are 12 points. Now, if all 12 are collinear, any 4 you choose, you will get 1 quadrilateral. Any 4 you choose, you will get 1 quadrilateral. So the answer normally should have been 12C4. However, what is it that you are not getting? You will not get a quadrilateral if you choose these 4 points, correct? Because all these 4 points are lying on a same straight line. So you can't get a quadrilateral which is minus 4C4. You won't get it, so that should be subtracted. What else? This is the hint I'm giving you. think for 30 seconds, guys. There's one more thing that you will not get. There's one more reason why some quadrilaterals are missing. What is that? Something else should be subtracted. Think carefully, quickly. Let's see how many of you can actually, get the idea. Roosters, you have got the correct answer. Can you tell me what else have you subtracted? So the correct reason is, if in these 4 points which are in a same straight line, if I take these 3 points and a point outside this, then also I will not get a quadrilateral, I'll get a triangle. I am taking 4 points, but if 3 of them happen to be on this or in this line of 4 collinear points, then I will get a triangle, not a quadrilateral. So that is what I need to subtract. So what should I subtract? First, how many ways can I choose 3 points out of this 4? That is 4C3. And once I choose 3 points, this vertex here can be chosen from these 8. That is 8C1. So 4C3 is coming because of choosing 3 points from the straight line, and 8C1 is coming because of that 4th vertex that you're choosing from the 8 non-collinear points. Hence, the answer will be this part. If you simplify, you'll be getting the answer as option A. Clear? So that's the beauty of this particular problem, a small change, right? So that's the reason why I keep saying that PNC is tricky. Let's go ahead to the next question. Here's the third question, again a tricky one as usual. Try to give me the correct answer. Let's see how many of you will get the correct answer for this. Varun, why did we subtract? Because when I took 12C4, everything was included in that. 12C4 means any 4 you choose, you'll get a quadrilateral. But that is not true, right? All 4 points, if I choose on a straight line, you're not getting it. But 12C4 included that, so I should subtract something which is unnecessarily included. Clear, Varun? Any answers, guys? That's about a minute. Vicky, is that a question or an answer? Okay, so let's see what happens when 0 is there. So this is the reason why I'm saying it's tricky is because whenever you come across these digit based questions where there is a 0 present and you're dealing with an even number, the best way to do this is break it into 2 cases. Case 1, the number ends with a 0. Case 1, the number ends with a 0. Case 2, the number does not end with a 0, but it is an even number. So if it is not ending with a 0 and if it is an even number, it has to end with a 2 or a 4 based on this question. Now, if 0 is already there, which means this can be filled only in one way because that's already filled. If it is 2 and 4, 2 or 4, it can be filled in 2 ways, right? It can be filled in 2 ways. Now let's fill the other portions. So now 0 is already gone. So repetition is not allowed in the first case and second case, both cases. So in the first case, out of the total 6 digits, 1 digit is written, which means I am now left with only 5 digits. So any of the 5 digits can come in the first place, 4 digits can come in the second, and 3 digits can come in the third. So the total number of ways in which the first case can happen is 5 into 4 into 3, which is 20 into 3, 60. Second case is where 2 or 4 are written at the end. Now there is a problem. 0 is still left out. And we know because it is a 4-digit number, your 0 cannot be in the first place. So in PNC, the basic thumb rule when you're filling or when you're doing some task is always start with the task which has maximum restrictions or minimum options. Then go to the task which has the next maximum restrictions, next highest restrictions, or next fewer options. So I started with this because that has 2, which is the least number of options. Then out of these 3 tasks of filling, I will go to the first one. Why will I go to the first one? Because there is an extra restriction there. And what is the restriction? 0 cannot come. So now remember, there are 6 digits with you. Out of 6 digits, 2 or 4, one of the digits is gone. So remember, there's total 6. 1 digit is already written. And 0 again cannot be written, used in the first place. So out of 6, 4 digits only are available for me. So this can be filled up in 4 ways. Now when I come to the middle 2 tasks, there is no problem. There is no restriction because 0 can come there. Hence, I have total 6, out of which 2 are already written. At the first and at the last, 2 are already written. So remaining 4 can come here and 3 can come here. So this is your answer for the second case. So 4 into 4, 16. 16 into 6, 96. So the correct answer is 96 plus 60, which is 156. Okay, so the logic here is when you are dealing with 0 and an even number, usually it's best to break it into a case where it is a 0 ending number and a non-zero ending number. That's the best way to solve this question. Okay, let's move on to the question number 4. Here's the question coming. This is again a very nice question. Try it out. With options, Varun, it's difficult to solve using options in P and C. Okay, it's a bit difficult to solve using options using P and C. This is one topic where options might not really be helpful to you. Okay, that's about 2 minutes given to you. Any idea, any answer? So here I'll explain the concept behind this question, where we are talking about some things which are not supposed to be together. Okay, so some things are not supposed to be together. So the logic for this kind of a question, it could be for letter arrangement, it could be a group of people made to stand in a straight line where they will say A, B, C are enemies, so they don't want to stand next to each other. Some question can be created like this. Okay, so how do we deal with a question where things are supposed to be separated out? They are not supposed to be next to each other. The logic is simple. First, when you're looking at such a question, write down the others who can be together, who may be together. There's no problem with them. Write down the others first. So who are the others? Here the consonants should not be together, which means the vowels may be together. So first write down the vowels. So what are the vowels? I have E, another E, I have a, I have a U, and I have another E. So the logic here is somewhat like this. Make these people or letters sit, and in between them, okay, I'm using O, so it might get confusing. In between them, yes, so these are the positions. Think of these as your seats. So what are the seats? You have seat number 1, 2, 3, 4, 5, 6. You have 6 seats now. In these 6 seats, you make the others who can or who should not be sitting next to each other be made to sit. Now what happens because of this? Because these are alternate seats, irrespective of where the consonants are sitting, they will never be next to each other. So the logic for this kind of a question, is always first take out the people who should not be sitting next to each other, make the others sit first. In between the gaps, every gap count it as a seat, including the endpoints. Out of these endpoints, now you choose how many ever seats you want depending upon how many people are supposed to be seated. In this case, we have 6 people and 6 seats because there are 6 consonants. So everything is perfectly matching. Had it been 3 consonants, I will choose 3 seats out of the 6 seats. 3 are enough because I don't need all 6. Right? So that's the logic. So here everything is matching, so there's no problem. Anyway, so let's take a look at it. First, I have to make my vowels sit. 5 vowels in 5 places. 5 vowels in 5 places. How can they sit? I can make them sit in 5 factorial ways because n things to be arranged in n places is n factorial. However, you can see that E is repeating. Now when things are repeated, I hope you know the basics. 5 factorial is only true if all the things are distinct. But if there are some things which are identical, you will have to divide it by 3 factorial in this particular case because there are 3 E's. Okay? Kaushal, yes, any vowel can sit in any of the 5 C's because the question only says consonants should not sit together. So 5 vowels in 5 places, first make them sit, then you put another chair in between them. So you will have 5 vowels in 5 places, which is 5 factorial, but because there are 3 vowels which are exactly looking the same, you have to divide it by 3 factorial. Then you will have 6 places in between. 6 places, 6 people can be made to sit in 6 factorial ways. However, in these consonants also, there is a T which is repeating, there is a R which is repeating, so T is repeating, R is repeating, is there anything else? M is not repeating, T, E, M, P is also not repeating. So only T and R are repeating. So you need to divide it by 2 factorial and 2 factorial. This is your answer. This is your final answer. Okay, clear? So the logic here is 5 factorial because of the vowels. Then the 3 factorial is coming because of the repetition of E. Then the 6 factorial is coming because there are 6 consonants and 6 in between places. So 6 factorial ways. And the 2 factorials are coming because T is repeated and R is repeated. So this is your final answer. If you simplify, you will get the answer as 3600. You'll get the answer as 3600. Okay? Alright. Is that clear, guys? Let's move on to the next question. Here is the next question. This is an extension of the previous one. So here, it's a question where some people are never together, some people are always together. So how do we deal with this? It's a mixture of last one with an extra combination of 2 people are always supposed to be together. I'll give you 2 minutes to think about it. It's a very nice concept. Let's see how many of you will be able to understand this. So PNC is one topic which is, in my opinion, very lengthy. There are so many concepts for you to remember. But the number of questions that come does not justify the amount of learning you need to have, frankly. But yeah, it's a beautiful topic, so I love it. So I always talk about it. But you need to decide. So many concepts which are there to be learned, and the number of questions in CAT are only 1 or 2. Does it make sense? That's very good, Vicky and Krishna. Awesome. That's the correct answer. So let's take a look at how did we end up getting B as the correct answer, which is good, given by Kaushal, Krishna, Vicky and Sri Vishnu. Awesome. So the logic here is combination of two concepts. The two concepts are some people are always supposed to be together, some people are never to be together. So we already solved how to deal with never together. We are going to include the concept of always together, right? So let's take a look at it. So the concept of always together is, we have how many? 7 people. So let's say the 7 people are A, B, C, D, E, F and G. Let us say A and B should always be together. Let's say they are best of the friends, they always want to be together. And D, E, F never want to be together. So they are enemies, they don't want to be next to each other at all. So the concept for never together is you put the others first. But who are the others? Now when you're looking at the others, so C, D, E should not be together. So I will place the others first. But when I'm looking at others, I have to make sure that A and B are always together. So the mini concept of always together is when some people or some group of things are supposed to be bunched, you combine them and call it as one person or one item only. Don't call it as A and B, call it as one thing called X. So now you have X, C, D, E, F and G. This is the new question now. Now the restriction is only on C, D, E. C, D, E are 3 people, they should not be next to each other. That's all. Then what happens? You will obviously place X, E, F, G, X, F and G first, because that's the logic we learned previous question. If C, D, E should not be next to each other, then place the others. So I will place my X, I will place my F, I will place my G in 3 places. How many ways can I do that? I can do that in 3 factorial ways, because at 3 places, 3 people. Now I will place C, D, E. What are the gaps? 1, 2, 3 and 4 places, 4 gaps. In these 4 gaps, I will have to put 3 people. How can I do that? It is 4P3. Permutation of 3 people in 4 places. That is 4P3. But the task is not over for us. Now we will have to look at what is happening inside this person called X. X is actually not X. X is A and B. So it can be A and B or it can be B and A. So 2 factorial because of the arrangement that can happen within X. So what we did here is, first we combined these A and B and made a new question and solved it, assuming that the C, D, E should not be together. We got an answer. This is our answer. Then we saw that, okay, we did a small change. What is the change? A and B I combined into X. Now I have to go back X to A and B. So X, when I'm writing it as A and B, actually 2 people, they can interchange among themselves. So it is 2 factorial. Had it been 3 people, A, B and C, then 3 factorial will come, because A, B, C can interchange in 3 factorial ways. Okay, but all of them will be between these 2 positions, So 2 factorial. So the answer will be 3 factorial, 4P3 is 4 factorial, 2 factorial. So this is basically 144. That is your answer. Clear? So this is the best scenario to talk about some people together, some not together. It's a combination of both concepts. So it's a really nice one and good to see that at least 3-4 of you have been able to answer this. Let's move on to the next question. Here is a very straightforward question. I think you should be giving me the answer in 30-40 seconds. Your time starts now. 40 seconds, give me the answer to this. Okay, was it 244? 3 factorial is 6, 4, 3 is 12. Ah, 24 into 2, my bad. This is 24 into 12. Okay, this is 288. Okay, I think this is supposed to be 288. My bad, guys. I think there's a small calculation error when I was making the question. I took 4 factorial and 3 factorial as same. My bad. Thanks for pointing out, Vicky. So it's 288 is the correct answer, not 144. Alright, so the correct answer here is C, 11. So basically a handshake happens when two people are brought together. So basically if there are n people, any two you choose, you will get one handshake. So how many pairs can I form NC2? NC2 is n into n minus 1 by 2 and this is 55. Which means n into n minus 1 is 110. Now don't try to convert this into a quadratic equation, just try to split this 110 into two numbers which are consecutive. So 11 into 10, you can observe 11 into 10. So your n is 11. Hence the answer is option C. Simple. Okay, so the logic here is any two people you choose, you will be getting one handshake. So to get 55 handshakes, you need NC2 people. So NC2 is basically n into n minus 1 by 2, which is 55. By the way, the last question, previous question, the answer is not 144, it is 288 because this 4 factorial is 24, this is 6 and this is 2. So the answer should be 288 guys, not 144. So please keep that in mind. Okay, let's move on to the next question. This is again a very interesting one. In fact, all these questions are simple, not very lengthy to calculate, but interesting. So let's take a look at it. I'll give you another 2 minutes max to solve this. The time starts now. Abhishek, that is not correct. Please verify carefully. Squares are not just the smaller squares. You can have bigger squares also. Krishna, 11 is not there in the options. I think you are referring to the previous question. Okay guys, so let's take a look at this particular question and what is the answer to this. None of you got the correct answer. The correct answer happens to be 40. So let me draw the figure correctly. Yes, so if I draw, you have 5 parallel vertical lines. So don't mind my drawing. Assume these are parallel. 1, 2, 3, 4 and 5. And 6 parallel horizontal lines. So 1, 2, 3, 4, 5 and 6. So yeah, wow, I've managed to get a really good figure. Never happens. Anyway, so these are the lines given to you, and they mentioned that the distance between any two adjacent parallel lines is same, 5. The 5 is actually of no use to us. It basically means that any two adjacent lines are evenly spaced. Now, clearly all of you know this, 1, 2, 3, 4, like this. How many will you get? You will get 1 cross 1. So this is one block. So 1 cross 1 block, you will get totally 20 such things, because you have 4, 5, 6, 7, 8, like this. If you count everything, there will be 20. But if you observe, I will be getting a 2 cross 2 block also. What is a 2 cross 2 block? 2 cross 2 block will be this. This will be a square. This will also be a square. how many squares will I get like this? So if you count it carefully, 1, 2, then 3. Okay, so one horizontal row I got 3. Similarly, how many vertical will I get? 1, already 1 is there, 2, 3 and 4. So horizontally I am getting 3, vertically I am getting 4. So it is 3 cross 4. So 3 cross 4 is 12. So basically this is 4 cross 5. This is 3 cross 4. That is the logic. Similarly, I can get a 3 cross 3 square. What is a 3 cross 3 square? Let me use a different color so that you can follow. So 3 cross 3 is this big one. I don't know, it's too light. Let me change it into a darker color. This color. Okay, how many such squares can I get? So 1 is here, then I can take one more like this, 2. So horizontally I am getting 2 now. Similarly, vertically I'll get 3. So this will be 2 cross 3. So this is 6. So you can see the pattern emerging. Similarly, you'll get 4 cross 4. 4 cross 4 will be 1 cross 2, which is 2. This should be your total answer. So the total answer is 20 plus 12 plus 6 plus 2, which is 40. Hence the answer is option A. Guys, counting squares, the best way to count squares is to start with how many 1 cross 1 will I have, how many 2 cross 2 will I have, how many 3 cross 3 will I have. And to get this 1 cross 1, 2 cross 2, 3 cross 3, take a look at how many are there horizontally, how many are there vertically. Take the product of that. Horizontally, if there are 4, vertically there are 5, there will be totally 4 cross 5. Okay? Horizontally, if it is 3, vertically it is 4, then 3 cross 4, which is 12, and so on and so forth. Clear? So that's the logic. Oh, if I change this question, guys, and if I say, how many rectangles are there? Then what will be the answers? How many rectangles? Same question, but instead of squares, I'm asking you to count rectangles. What will be the answer? Yes, Kaushal, kind of similar logic in cubes. Kind of similar. Again, depends upon the question. But anyway, right now give me the answer for rectangle. Don't simplify it, just give me in the NCR format. Anyone? This should be done faster. No one? So guys, the logic for rectangle is any 2 lines horizontally you take, any 2 lines vertically you take, you will get a rectangle. The size doesn't matter. Because in a square, you need to make sure that it's a 1 cross 1, 2 cross 2, 3 cross 3. But in a rectangle, it's easy. Calculating the number of rectangles is easy. Why is it easy? Because any 2 vertical lines and any 2 horizontal lines you take, in between you'll get a rectangle. So it could be a square also, because all squares, remember, are rectangles, but not all rectangles are squares. So any 2 vertical lines combined with any 2 horizontal lines, you will get 1 rectangle. So how many such combinations can I have? I can choose 2 from 5 parallel in 5C2, and I also have to choose 2 from 6 vertical. So, or 6 horizontal. So this is 6C2. This is the number of lines. So this is how much? 5C2 is 10, 6C2 is 6 into 5 by 2. So this is 150. So the number of rectangles will be 150. Clear? Alright, let's move on. So remember this very important concept of finding the number of rectangles. It is number of horizontal lines, C2, into number of vertical lines, C2. But if it is square, it's difficult. There's no direct formula per se. Depending upon how the structure is, you will have to start counting them 1 cross 1, 2 cross 2, 3 cross 3. Okay, let's move on to the next question. This is again a tricky question. Try to do this. I'll give you about a minute and a half. Kaushal, the rectangle answer was 150. 150. Right? Anyone? Any answers in this? Let's take a look at this. You basically want two teams, each team with two people. 180. Yes, that is correct, Abhishek. Very good. Kaushal and Abhishek. That is correct. So you need two teams. 1, 2, 3, 4. Let's say team 1 and team 2. But they will play against each other. It's like, imagine badminton doubles or table tennis doubles or tennis doubles. Okay. So you need two teams. Each team will have two people and they're fighting against each other in one game. So which means in one game you'll have 4 people. This is how you need to fill. Now there are 6 families. Each family has one brother and one sister. Now the team it's a mixed doubles team. So there should be one boy, one girl in every team. And in one game, no two of them should be siblings, which means all 4 should be from different families. You can't have a brother and sister in the same team or opposite team also. So let's start working on this problem. So I will take that first team. I'll fill the first person. First person is no problem. Anybody can come here. 6 people, 6. So let's say it's a boy. Boy, girl, boy, girl. Now the first boy can be chosen in 6 ways. Once the first boy is chosen, now it's a turn for the girl. Remember, whoever comes here, that person's sister cannot be there anymore. Because you cannot select two people from the same family into this game. So the second person who is a girl in the first team can be chosen in 5 ways. So let us say family A and family B. Family A person is here, family B person is here. Now when I go to the second team, the opposition team, please remember the boy, already out of the 6 boys, 1 boy is gone. And out of the remaining 5 boys, family B's boy cannot come. Why can't the family B's boy cannot come? Because family B already sent the sister there. So the brother of B cannot come. Which means family A boy is gone, family B boy cannot come. So the remaining are only 4 families. All these 4 families can come. Any one boy from the 4 families can come. And next, the girl's turn. Remember, family A, girl cannot come. Family B, girl is already there. Family, let's say this is C family is coming here. Family C, boy is there, which means family C's girl cannot come again. Therefore, there are remaining 3 families. Any of the 3 girls from the 3 families can come, so it is 3 ways. So the total number of ways is 6 5s are 30 into 4 3s are 12, which is 360. But keep this in mind that in a game, whether you call this 1 and 2 or this as 2 and 1, it doesn't really matter. For example, if I take the case of B1, G1, let's say the boy 1 from family A is BA and GB, and I have BC and GD. These are my 4 players. In this, when I wrote this 360, it also counts this case, this scenario. It counts the scenario where BA is here, GB is here, BC is here and GD is here. This should not be counted twice. It should count it only once. But when I wrote this 360, both the things have been counted because I started taking it as team 1 and team 2. But remember, when I said team 1 is this group and team 2 is this group, it is same as team 1 as this and team 2 as this. But in my counting, I counted it twice. So I have to divide this by 2 because everything I counted twice. But in a game, once this game is over, I will not do the same game again, right? It should be a different game. So divide by 2. So the answer should therefore be 180. Clear? Right, so guys, with that we come to the end of the session. I hope you guys learned certain things, learned certain concepts and enjoyed the session. So please be subscribed onto our channel as well as click on the notification button. We are having a lot of CAT and MAHCT videos coming your way on YouTube, as well as download our app. We have a lot of sessions planned for you on the app specific as well. It's not a repeat session. There will be different session on your app, different session on YouTube. So please be there on both of them. And of course, we have an Instagram channel which is very vibrant with a lot of questions coming your way. So if you are there on Instagram, please follow us on Instagram because you will be getting a lot of free content there. Thank you, my friends. I have one doubt coming up. Would you please summarize the square question? Okay, Vicky, I will take it up very quickly. The square question is simple. If I have 1 cross 1 squares, there are 4 squares horizontally and 5 squares vertically. So 1 cross 1 will give me 20. If I want to take 2 cross 2 squares, I will get 3 squares horizontally and 4 squares vertically, which means total I'll get 12. If I want a 3 cross 3 bigger square, then 2 horizontally and 3 vertically, which is 6. And 4 cross 4, I will have 1 horizontally and 2 vertically, which will give me 2. So all these squares will add up to 40. That is the logic. Clear, Vicky? Fine. Thank you, my friends. I will see you in the next one, and all the best for your preparation.